This is question number 11. Concentrated aqueous sodium chloride. Focus the word concentrated sodium chloride and dilute sulfuric acids are both electrolyzed using inert electrodes. So it is carried out in different container. These are the two different experiments. Which row identifies the product at the cathode in each electrolysis? So see here, as it is concentrated aqueous sodium chloride. So if it is concentrated, then the chloride ion instead of hydroxide ions, preferably oxidized to produce chlorine gas at anode. While sodium being more reactive than hydrogen, it is not reduced. Instead of this, hydrogen is reduced to produce hydrogen gas. So sodium cannot be reduced. So first see in sodium chloride, uh, what was the question? Which will identify the product at cathode? So at cathode, hydrogen gas would be produced. So whether it is correct or it is correct. At cathode, chlorine cannot be produced. Okay. So what about the other side? In another cell, dilute sulfuric acid. Dilute sulfuric acid means uh, hydrogen gas is produced at cathode, and hydrogen gas is produced at cathode while oxygen at anode. So it is asked about cathode. So both the answer would be hydrogen. So the correct option is B. Question number 12, it is also related to electrolysis. Which row are correct for each electrolyte? So different electrolytes are given here, and reaction at cathode and product at anode. So in this reaction, product is also given here. So what could be the correct answer? Remember that reduction occurs at cathode and oxidation occur at anode. So if you remember this point, so you can understand it could be correct, it could be correct, it cannot be correct, it could be correct, but as if you have an aqueous solution, whether it is concentrated or dilute, sodium and potassium can never be reduced. So it is not possible. See, I have not seen the product at anode. I ignored it because I can identify from only one point that reduction at cathode and which species cannot be reduced. So here both are possible in term of reduction, but see what are the electrolytes? Dilute aqueous potassium chloride. So if it is potassium chloride, so potassium cannot be reduced in presence of hydrogen ion. So hydrogen ion will be reduced to produce hydrogen gas, so it is correct. And as it is dilute, so chloride, instead of chloride, hydroxide will be oxidized to oxygen gas. So oxygen is the product, it is correct. So option 1 is completely correct. Number 2, concentrated hydrochloric acid. So definitely there is only one positive ion. So hydrogen will be reduced to hydrogen gas. So hydrogen ion is reduced. Okay, no problem. But as it was concentrated, so chloride ions are there in concentrated, concentration is high. So instead of hydroxide, chloride will be oxidized to chlorine gas. So 1 and 2 both are correct. 3 and 4 are wrong. So the correct option is A. Question number 3 is also related to electrochemistry and all as well as for energy from the chemical reaction. Which statement about hydrogen oxygen fuel cell is correct? You know, this is hydrogen oxygen fuel cell. So hydrogen is extracted from clean dry air. You know, no hydrogen is there in clean dry air. So not possible. The only product is carbon dioxide. How can it be correct answer? How? Hydrogen oxygen fuel cell never produce any such greenhouse gas. See, the reaction is endothermic. It is a fuel cell. How can we use the endothermic reaction here? So it is also wrong. So the correct option is only D. But see, what is this? No toxic gases are produced. Yes, no toxic gas is produced. But you know that the negative effect of hydrogen oxygen fuel cell is that it produces water, and water vapors itself are greenhouse. They absorb infrared radiation. Now, question number 14, which statement defines the energy of activation? So you think about what is energy of activation. It is the minimum amount of energy required to carry out a reaction. So this amount is energy of activation. So the energy that potential energy that they already possess, and this additional energy is required. So now read the statements. A, it is the minimum energy that colliding particles must have to react. Yes, it could be. It is the minimum energy that endothermic reaction taken from the surrounding. It is not necessary whether it is exothermic or endothermic. The graph that I have shown here, it is for exothermic. See, the energy of product is lesser, energy of reactant is higher. So definitely it is for exothermic, and it is correct for exothermic as well. And it is also correct for endothermic as well. So whether the reaction is endothermic or exothermic, so this is wrong because of this endothermic, because it is not specified for endothermic. It is the maximum energy, so we don't need to read it more, okay? Because it is the minimum energy. So correct option is A. Now this is question number 15. The equation for the complete combustion of ethane is shown here. It shows that 2 moles of ethane is reacted with 5 moles of oxygen to produce 4 moles of carbon dioxide and 2 moles of water. The bond energies are listed here. And what is the enthalpy change? Enthalpy change means delta H is to be calculated of the reaction. But when 1 mole of ethane, so actually it is for 2 moles, we have to calculate for 1 mole is completely burned. Okay, so this numerical needs calculation. So first we should see the reactant side. If for 2 mole it is this, so for 1 mole we need 2.5 mole of oxygen, and 2 moles of carbon dioxide would be produced, and instead of 2 mole, 1 mole of water would be there in the product. So now see, for 1 mole of ethane, which bonds are there? So it is multiplied by 1, no problem. It would remain same. 837, and in 1 mole there are 2 moles of carbon hydrogen bonds, so it would be multiplied by 2, so it would become 830, and it is also on reactant side, so 2.5 mole, so it is for 1 mole as it is here for 1 mole. This whole data is for 1 mole, so it is multiplied by 2.5. So let's see what is this. So it is calculated for 98 multiplied by 2.5. It is 1245. So we have to add all these for reactants. So reactant side energy, it would be positive, and we have to add all of these. 837 plus 830 plus 1245. See, what's this? So it is calculated that it is 2912. So energy on reactant side is 2912 kilojoule. Now see for the product. So for the product, there would be 2 moles of carbon dioxide and 1 mole of water. So for 2 mole of carbon dioxide, there would be 4 moles of such bonds. So it would be multiplied by 4. And for 1 mole of water, there would be 2 moles of oxygen and hydrogen. So oxygen hydrogen bonds are 2 moles. So multiplied by 2. And see what should it be? It is 8 for the 24. Sorry, 8 for the 32. And 4 5 is the 20. 3220. And for this, better to use calculator. So it is 928. So on product side, there would be minus because bonds are formed. So energy would be released. So it is 3220 plus 928. So see what is the final answer. It is 4148. So this is the product side. So now for delta H, we can calculate in either ways. One way is to add all the energies, summation of all the energies for bond making and bond breaking. So for bond making, plus summation of bond breaking. So here the summation is in negative in for bond making. It is 4148 plus it is 2912. So your answer is answer would be in minus 1236. So the correct answer is no, correct answer is B. So B is the correct answer as per our calculation. And another way of calculating this delta H is the energy energies on the reactant sides, all the enthalpies on reactant side minus enthalpy on product side, sum of all enthalpies. So it is 29112 minus, and we don't use this minus sign here. We use the whole value, that is 4,148. This minus sign is from the formula. Then we will get the same answer. It is minus 1236. So we can either use any one of these strategies. This is question number 16. In experiment number 1 is small lumps of limestone are added to the dilute ethanoic acid at 40 degrees Celsius. The volume of the carbon dioxide released is measured at regular time interval. A graph of the result is shown. Okay. While which changes give the result shown in experiment number 2? So first they have described uh, this experiment number 1, but experiment number 2 is not described here. So let's see what's there. In experiment number 2, they have shown this answer A, large lumps. Yes, large lumps could be there because small lumps are used in the first one. So if we use the large lumps, then it is the better curve. It has less gradient. Gradient is lesser here. It could be correct. And temperature. See what is the temperature here. It was the 40 degrees Celsius. So it would remain the 40 degree. Yes. Otherwise, if temperature would be greater, then rise in temperature increase the reaction rate. On every 10 degrees Celsius, the rate of reaction becomes double. So although for using the large lumps, rate of reaction decreases, but at high temperature, it would again increase, and it is difficult to predict for us. So this graph shows that the correct option would be A. Question number 17. In the Haber process, nitrogen and hydrogen are reacted to make ammonia. Reaction is given here. The forward reaction is exothermic. The conditions produce the maximum yield of ammonium. You know, there are total 4 moles of reactant and 2 moles of product. So if more reactants, there are more number of moles of reactants are there as compared to product, then at high pressure, equilibrium shift towards right means we will get more ammonia. So according to pressure, it should be high. And what about temperature? As it is mentioned that it is exothermic reaction. So for exothermic reaction, temperature should be as low as possible. So the low temperature is the correct option. So B is the correct option for this question. Question number 18, the Ostwald process is used to make nitric acid. The condition used in this process are catalyst containing a transition element, a pressure of 10 atmosphere, a temperature of 800 degrees Celsius. Which of these conditions are used in contact process? Contact process for sulfuric acid. Yes, there we use, this is the same thing that we use a catalyst containing transition element. We use their vanadium pentoxide, but this high pressure and high temperature is not required for contact process. So the correct option is only B. Question number 19, hydrogen iodide is dissolved in water. So it will produce hydrogen ion and iodide ion. Okay. Which would describe the final color seen when the solution is tested with damp red litmus paper. So what would be the change? No change, because this is the acidic condition. So litmus remains red. And with acidified potassium, potassium magnate 7, KMnO4, KMnO4, it is purple in color. So first is that damp red litmus paper remains red. So answer is either C or D. A or B cannot be the answer. Okay, so leave it. Now we are confused about brown and colorless. So actually, when it reacts with iodide, so definitely its purple color, it becomes colorless because it forms manganese 2 plus ion, which gives very light pink color. So ultimately they are colorless. But on the other hand, when iodide is oxidized, it produces I2, which gives ultimately brown color. So actually, in this condition, it will be converted into brown. So the correct option is C. Now, question number 20. Which statement about aqueous ethanoic acid are correct? Aqueous ethanoic acid. This is ethanoic acid. There are 3 hydrogen atoms here as well. It can be produced by oxidizing ethanol with potassium iodide. No, it can be produced by oxidizing ethanol with potassium dichromate 6 or potassium magnate 7, but not with potassium iodide. So 1 is wrong. It reacts with magnesium to produce hydrogen gas. Yes, this is acidic hydrogen, so it can produce hydrogen gas, correct. It has an approximate pH value of 3. Yes, it is a weak acid, so pH would be around 3 or 4. It could be correct. It produces ester called methanoate. No, it has 2 carbon atoms, so the ester produced here would not be methanoate, but it would be ethanoate. Ethanoate. So it is also wrong. So the correct option is 2 and 3, 1 and 3, 1 and 4, 2 and 3. So C is the correct option.